Welcome to Chapter 2. We'll be focusing on Section 2.2 Histograms. The best way to do this video is to have your textbook out, and you will need your TI-84 and your notes. Take lots of notes, pause the video, try it on your own, and feel free to watch the video several times and with different data sets. Well, a frequency distribution, which is our previous section, is useful for summarizing and investigating the distribution of data. An actual better tool is a histogram, which is a graph that's easy to interpret more so than a table of numbers. So we're going to be looking at histogram, relative frequency histograms, distribution, skewness, and normal distribution. A histogram is a graph that's very similar to a bar graph, but it's equal width, everything is equal width, and adjacent, meaning there are no gaps in the bars unless there are gaps in the data. The horizontal scale, so the scale here on the bottom, represents the classes of quantitative values. So we talked about the classes with the frequency distributions. And the vertical scale, is the frequency, those tally marks, and the height of the bar is the frequency value. So it visually displays the shape of the distribution, and we'll be doing this again later, but let me get out here. We can kind of see that it goes low and then really high, and then it kind of tapers off again. So we can see the center of the data, the way it's spread out. We can see if there's any outliers. We can see a lot when we look at a histogram. So we're actually going to be constructing our histogram with a TI-84, and I've got mine right here. So hopefully you can follow along with me. So we're going to create them in our calculators, and we're going to need to use the class midpoints and frequencies of the classes. So those class midpoints that we figured out in our last section, we're going to be using here. So we're going to click the Stat button, and then we're going to hit Enter, and highlight L1, press Clear if you need to, and then press the cursor down if you need to. Mine already kind of started right there. And then I'm going to enter my midpoints into L1. So 99.5, 149.5, 199.5, 249.5, and 299.5. And then in L2, cursor over, we're going to enter the frequencies. So that's 11. And they should correspond with their midpoint. So always double check. Lots of room for error here. Oh, I already see an error. You may have already spotted it right there. 299.5. Now, because I saw that, I'm just going to double check here. Great. So after you've got that all in, we are going to turn on our stat plot. So we're going to hit second y equals and enter again to turn on plot 1 if it's necessary. And then we want to get over to the histogram. And then we want to make sure the X list is L1. If you're not sure, you can see L1 is in blue. So if it's not, you would hit second 1, and then oh, I see that I did not actually get us to histogram here. There we go, you have to hit enter. There we go. Okay. X list is L1, and our frequencies we put in L2. And then we're going to hit zoom. Out of there. Zoom. And you can click 9 if you want, or if you want to see where 9 comes up. Zoom stat. And you'll see an awesome bar graph, but you're like, wait, why isn't it the touching bars, the whole point of the histogram? So let's go back in. We're going to adjust the window. So we're going to go to Window. And the most important thing is we're going to go to our X scale, and this is where we want to change it to the class width. If we recall from the previous section, the class width is 50. And then we want to see the graph, and boom, there we go. So if we want to trace along, we hit the trace button, and we can kind of move all around and see those frequencies and see our beautiful histogram. So I encourage you to actually do that all over again on your own and make sure that you understand how to use your TI-84. Now, a relative frequency histogram has the same shape and horizontal scale as a histogram, but the vertical scale is marked with relative frequencies instead of actual frequencies. So what does that mean? That's the percents. So when we interpret histograms, we're analyzing the data, and we can learn, like we've already said, the center of the data, the variation, the shape, whether there are any outliers. So let's look at these common distributions. So we call this normal bell-shaped because it starts low, goes up, and then comes back down. This is uniform because all the data is about the same. This one's skewed to the right, and this one's skewed to the left. So let's go through this. So a normal distribution is roughly bell-shaped. A distribution of data is skewed if it is not symmetric and extends more to one side than the other. So something that is skewed to the right or positively skewed would have a longer right tail. We call these tails over here. So that's a right tail. And that's why you probably think like, well, it looks like it's leaning to the left. But it's skewed right because it's got a longer right tail. And it's skewed left if it's got a longer left tail. And we'll be talking a lot about tails in future sections. Now, when we look at normal data as a line on a scatter plot, a normal distribution would be the points are reasonably close to a straight line and there's no kind of other pattern that's going on here. So this would be a normal distribution of data. Not a normal distribution would be points that don't lie reasonably close to the straight line, or they have a different kind of pattern that's not a straight line. So here are two examples of not normal. And you may be thinking that the second one here looks normal, but there is a pattern going on here, and it's not a straight line. It actually kind of looks a little bit curved. And so that would not be a normal distribution. And that concludes section 2.2.